Hello everyone, this is Engineer Salase from Yale Academy and Brain Boosters, and today we are going to see chapter 27, and this is trade APIs. In the previous chapter, we have seen what is trade, what is the use of trades, and other trade related issues like concurrency, how the cause of the execution has problem, and we try to demonstrate with the provided code. So I encourage you to download the code and practice by yourself using Unix. And in this chapter, we are going to see the trade APIs. And the first concept is trade creation, how trades are created. This is the syntax, how to create and control trade. As you can see, we have the pthread header and we have int, and we have a function here, pthread create. And as you can see, pthread -t, this is thread, and we have const pthread attribute, we have the attribute void asterisk, we have asterisk start routine, this is void, and again we have void and the arg. So if you see thread attribute and start routine and arg, what is it? Thread is used to interact with the thread, and attribute is used to specify any attribute this thread might have, example stack size, scheduling priority, and other issues. Start routine, this one the function this thread start running in. Okay, this is the function this thread start running in. And arg, the argument to be passed to the function start routine. Okay, this is the argument. So any argument, a void pointer allows us to pass in any type of argument. So these are the concepts. And trade creation, if start routine instead required another type argument, the declaration would look like this. An integer argument, for example, if we need to pass integer here, pthread creator, and we have start routine. So if you see pthread creator, what it does is if we pass int, this is the syntax, first two arguments are the same, and routine return an integer, again pthread create. As you can see, we have void, first two arguments are the same as well. We have another code creating a thread. This is a simple code, you can download it and you can practice. So as you can see, we have type definition, structure, myArgT, then int a, int b, and we have myArgT, then we have the void function, myThread, void arg, then myArgument t, we have the pointer n, so myArgument t, as you can see, arg, then we are going to print the value. Here myArgument t is here, so the value a and b, so a and b will be print. In the main function int argc, then we have argv character, so pthread t, this is going to be p, we have done int, then my argument t, this is going to be arg, then arg s dot a, this will be 10, and argument for b will be 20. So pthread create, this will be p, the pointer, this will be p, then null myThread, okay, then the arg. Okay, so let's see, let's go to the code instead of the practice. Let's go to the code. So this is our code, and let's we already opened. So what I'm going to show you in this, these are the files. Okay, these are the files. So the first thing we can see it, for example, thread create C. We can start from thread create C. Okay, so what we can do, where is thread create C is this one. We can check, let's see, paste. This is a code. Okay, this is our code, and so we can compile it. Okay, I think the code I have here, we can compile it. GCC, as you can see here, I have this one, so we can copy this code and we can paste it here. Okay, then after that we can use this. Paste. So as you can see, 10 and 20 is already printed. Okay, that's what I want to show you. And the other one, if you want to see what we can do, cut and thread create C. We can take this, the thread create C, we can copy and paste it here. So as you can see, this is the code. So 10 and 20 is printed. Okay, the other, okay, let's continue and we'll come back. So this is the thread creation. This is the code also. So we have seen. Then we have wait for a thread to complete. This is a concept for the parent and child creation. If you remember process creation, the parent will wait until the child process end and some that kind of concept. In the thread also the same. For example, wait for a thread to complete, int pthread join, pthread tthread, and we have void and value. Then thread, this means specify which thread to wait for. Okay, the thread specify which thread to wait for, and value pointer, this one value pointer, a pointer to the return value. Okay, a pointer to the return value. This is the syntax. So because pthread joined return changes the value, you need to pass in a pointer to that value. So in general, this is the syntax. So thread specify which thread will be wait, and value pointer, a pointer to return value. Because pointer joined needs a return change the value, you need to pass in a pointer to that value. So we have also another code. I directly take it from the book. This also waiting for thread compilation, and as you can see, we have type definition structure, my argument t, int a and b are here, my argument t, then type definition structure, and my return t, int x and y, my return t also here, void, my thread, void arg, and my argument t, we have a pointer here, and my argument t, this is the pointer arg and printf. So we're gonna print a and b, and we have a pointer here. So my return t, we have again a pointer arg. This will be malloc size of my return t. So this will be in the heap. Okay, then r x is equal to 1, y is equal to 2. So return void r. This is the code. Let's get into it again. What we are going to do, so argc, this is the code, and as you can see, these are our cores. So if you want to see thread argc, so let's view it. Thread right. Okay, this one, thread create argc. Yeah, this one what we need. Copy and paste it. Yeah, this is the code, as you can see. Okay, and let's quit. Okay, so what we are going to do, we already make we can use make. It's already done already. It's already done already. So what I want to show you is thread create with return arg. This one, this is the code. So what we are going to do, we are going to compile it. Paste. So as you can see, the create with return arg. So the argument is 10, 20, and returned 1 and 2. So this is a simple example for wait. Okay, so let's continue again. So wait for thread compilation. This one we have seen it already, the code. So 10 and 20 and x and y was returned, and x and y is 1 and 2. So as per our code, the return was 1 and 2, and the argument 10 and 20 was printed out. This thread has been waiting inside of the pthread joint routine. Then this is the dangerous code. Be careful with how values are returned from a thread, okay? Because the issue is, if you see this my return tr, this is in the stack, allocated on the stack. This is very bad, because if you see our first code here, we assign it in the heap malloc. Okay, this is the pointer, and we assign the memory in the heap. But the issue is here, if you forget that, and if you make it in the stack, when the variable r returns, it is automatically deallocated. So it's very important point. Then simpler argument passing to a thread. This is another code, just passing in a single value. So this is the syntax again. We have my thread and we have int m, integer argument, printf, then return void, then argument, the argument was whatever given here +1, then int main, integer argument, then we have the character and argv, then pthread, we have p, and int we have m. So pthread create p null, then my thread, okay, void, then we have 100 here, pthread joined p void and m, then printf returned m, then return 0. I hope we have here. Okay, let's get into the code again. Let's get into the code. Pthread, the first thing, pthread, let's see the code. bi thread create simple. Where is this one? Thread create simple argc. Okay, let's see the code first. So this is the code. Okay, then what we are going to do, let's compile it. Thread create simple JS. Where is it? This one, create simple arg. Okay, this is the code we need. And paste it here, and as you can see, we have the 100 and returned 101, because as we have seen the code, it should add for the argument, yeah, it should add the argument. Here we have in the argument 100, then it should be, we add 1, so it is 101. So this is the code. Now let's talk about locks. And I encourage you to download the codes and practice for yourself. So provide mutual exclusion to a critical section. This critical section problem for concurrency, and when the process they want to access the memory at the same time, it will create problem. So this mutual exclusion to a critical section lock are important. So interface, this is the syntax. The first one, int pthread mutex, this is the lock, then pthread mutex t, then mutex, we have again int pthread mutex unlock, this is for unlocking, this is locking. So pthread mutex t and we have mutex. These are the syntax, the interface, okay. And using the lock, okay, initialization and error check, what we have is pthread mutex t lock, then we have pthread mutex lock, this is lock. Then in the critical section, as you have seen, x is equal to x plus 1, or whatever your critical section is. Then pthread mutex unlock, okay, this one is for the lock, that this is for unlock. So no other thread holds the lock. The thread will acquire the lock and enter the critical section. If no other thread holds the lock, then the thread will acquire the lock and enter the critical section. If another thread hold the lock, the thread will not return from the call until it has acquiring the lock. So it will not enter into the critical section, unless and otherwise no other thread hold the lock. These are the idea. Again, all locks must be properly initialized. One way, using pthread mutex initializer. So if we have a lock, we have to initialize it. So this is the syntax again: pthread mutex t lock is equal to pthread mutex, then initializer. We have the initializer. The dynamic way, using pthread mutex int initializer, okay. Then we have int rc, then pthread mutex initializer. Then the lock, we have null. So the assertion is equal to always check success. The other concept which I want to discuss with you, check errors. Errors code when calling lock and unlocking. So an example, wrapper, check here. Use this to keep your code clean, but check for failures. Only use if existing program is okay upon failure. So p mutex, we have the lock, and the pthread mutex, then we have the mutex, then here pthread thread mutex, then we have the lock mutex, then assertion we're gonna have 0. Those two calls are used in the lock acquisition. So let's see the syntax again. Pthread int pthread mutex try lock, and pthread mutex t, we have the mutex here. This is for the lock, and we have int pthread mutex, and we have time lock. So pthread mutex t, this is the mutex structure time space, and we have timeout. So try lock, this try lock return failure if the lock is already held. Okay. So return failure if the lock is already done. Time lock returns after a timeout. After the timeout, it will return. So these are the two calls used in the lock acquisition. Those two calls are also used in the lock acquisition. Let's see, try lock and time lock, as we have seen now. The same what we have seen here. So again, condition variables. Let's see what is condition variables. Condition variables are useful when some kind of signaling must take place between threads. Okay, when there is signaling between threads. Pthread condition, here we have wait. This is for the wait. Pthread t, and we have pthread mutex and pthread cond, that means condition signal, pthread condition t and cond. So this is the syntax. Let's see what it does. Pthread condition wait. Okay, pthread condition wait, put the calling thread to sleep. Okay, and wait for some other threads to signal it. So if you have this pthread condition wait, put the calling signal thread to sleep. But if you have pthread condition signal, unlock at least one of the threads that are blocked on the condition variable. So these are also the two concepts you don't want to miss. Again, the third calling wait routine. The first one is pthread mutex t lock. This is pthread mutex initializer, and we have pthread condition t int, this is pthread condition initializer again, pthread mutex, this is the lock, then this is while, okay, not if, this is while initialized is equal to 0, pthread condition wait initializer and lock, and pthread mutex unlock lock. This is the wait call releases the lock when a putting said caller to sleep. Before returning after being woken, the wait call reacquire the lock. So a thread calling signal return. If you see, this is for unlocking. So pthread mutex lock. This is for the lock and initialize the 1. When this is 0, it is lock. So when it is 1, pthread condition signal initialized and pthread mutex unlock. So it will be unlocked. So 0 and 1. Again, the waiting thread rechecks the condition in the while loop, okay, in the while loop, instead of a simple if statement. So here, as we have seen, it is in a while loop. So without rechecking, the waiting thread will continue thinking that the condition has changed even though it has not. So that is the idea. Don't ever do this. This is some of the recommendations in the book. A thread calling wait routine. If you say while initialized 0, then spin. And a thread calling signal routine initialized is equal to 1. It performs poorly in many cases. Just waste CPU cycle, and it is error prone. So these are the concept. And to compile them, you must include the header pthread edge and explicitly link with the pthread library by adding the pthread flag. So this is prompt gcc -o main.c wall and pthread. And for more information, you can go to in the main pthread, and we can see that. Let me show you. If you go to the man page, so we can just write man pthread. Okay. So as you can see, we have a lot of so pthread destroy, get affinity, get detach states, and you can go through and check all the syntaxes. So in general, this was chapter 27 of this book. I hope it was helpful, and I really recommend you to go through the books, download the codes also. The codes are available, and you can compile it by yourself and practice. And I hope it was this was helpful, and we will meet in the next chapter. I was Engineer Selassie from Hello Academy Brain Boosters. Thank you for watching. Bye bye. Thank you.